ROS developers, and welcome to a new open class number 142 already. And today we are going to be talking about URDF in ROS2. More specifically, how to spawn a URDF robot model into a Gazebo world using ROS2. All right? Then please let me know in the chat. I'm going to switch right now to my computer screen so that I can start seeing your messages and everything. And please let me know if everything is fine, sound is fine, image is fine, so that we can continue normally. So yeah, then let me switch right now to my computer screen. There we go. Let me come here to the workshops and make sure that everything is fine. Okay, I can see the streaming is there. Hello, David. Hello, Volker, Yakmur, Martin. Hello, everybody. David is saying beat and sound are great. Excellent. Excellent. All right, then we are ready to start the class. Then, as always, let me remind you, the first thing that you have to do is to fork and open the class rosject. So all of you, please click on this button here, which is right in top of the chat. I'm going to click it myself right now. And this is going to open, in my case, the rosject automatically. In your case, this is going to copy the rosject to your workspace. So you are going to have a copy of this rosject forever. Which means that you are going to be able to use it today in the class, of course, but you're going to be able to use it also tomorrow, next week, next month, whenever you want to review the topics that we are going to do here. So you are going to have this project forever, okay? Then, yeah, so the project is going to automatically open as well, as you can see in my case, and it should display here the notebook for today's class, which is number 142. So make sure that you have the correct notebook. And then here at the right side, as always, you have the streaming panel so that you can see what I am doing, what I am saying. You can hear me as well. You have the chat in case that you have questions, comments, whatever you want. And yeah, so let me know, so far so good. Have you been able to get and open the rosject? Any issues so far? Okay, Martin says none yet, rosject not running. Perfect, perfect. Okay, then we are ready to get started. So yeah, first of all, I want to point out some requirements for being able to follow this class normally without difficulties. First of all is that you should have some basic knowledge on Linux, all right? How to work with terminals, especially the most common terminal commands. It would be good also, but it's not mandatory to have some basic ROS2 knowledge, or for instance, on how launch files work and so on, but it's not mandatory. In any case, you can get all this knowledge in our academy. I have left you links here that take you directly to the courses. So yeah, in case you are interested, you are lacking some of this knowledge, you can get it here in our academy. All right. As you can see, some of the courses are free, so you can do them completely for free without having to be subscribed to the academy or anything. And then finally, this class is going to be about ROS2 URDF. All right, so working with URDF files, as in this case, spawning URDF files in ROS2. All right, and then so this is a very little part of what you can do with URDF files, but you have here also. I was logged out for some reason. Let me come back. All right, there I am back. I don't know what happened there, but I was logged out. All right, Yeah, then as I was saying, you have also here a link to the complete URDF for robot modeling in ROS2. All right, we have published this course today, so it's brand new. And then, yeah, so today we are going to be doing and practicing with a very little fraction of what URDF files provide. All right, but in case that you want to go deeper, learn more subjects related to URDF files in ROS2, then you have also here the complete course in our academy. All right. Okay, then, yeah, so with the proper presentations being made, let me start already with the, okay, I have been kicked out again. All right, this is really strange. Okay, I am back. Let's hope that this is the last time that I am kicked. I don't know what's going on. Somebody is logging into the account or something. All right, then yeah, let me get started. All right, so so yeah, as always, before actually getting started, let me tell you that this is an interactive class. Okay, what does this mean? This means that the attendants to the class are not supposed to be just there listening and watching to what I am doing, but you are supposed, I want you to be practicing with me. Okay, so here in the notebook you are going to find all the instructions, all the different steps that I am going to be doing myself, so that you can reproduce them yourself there in your projects. Okay, so this is the goal, that you are going to be able to practice what we are going to be doing and reviewing during this class. All right. Okay, then, yeah, so our goal for this class is basically to spawn a URDF file into a Gazebo world, okay? Then, for this, the first thing that we need to do is to start Gazebo, right? So we have to create some kind of Gazebo world and start it so that we are able to spawn things, in this case a URDF file, into this Gazebo world, right? So we are going to start with the practice right now. Then the first thing that we are going to do is to run these commands that we have here, where basically we're going to be creating a new package named myboxbot Gazebo. Then we are going to create some folders in this inside this package. We are going to create also a launch file in order to start a new Gazebo world. We are going to create a world file as well, which is the world that we are going to start. And then, yeah, here at the end, we are going to download some models that we are going to be spawning into the Gazebo world. Yeah, so we need to have these models available so that Gazebo can get the information of these models and they can be spawned into the Gazebo world, right? So yeah, let's start right away. Then the first thing is to start a new terminal. So we are going to come here to the first icon that we have here in the bottom bar, the first one. So let's click here, and this is going to open a new terminal, a brand new shell. All right. Then you can make it bigger, smaller, however you want. Also, you can open other shells, extra shells, in case that you need them. We are going to need them later by clicking here in this plus icon. All right. Okay, then, oh, and of course, as you can see, this one is named Hi. You can rename your shells with whatever you want, okay? So that you know what you are doing in each one of them. All right, then let's go with the first one, and let's start running here some of these commands. So first of all, we are going to run this one. So what I suggest when you see commands like this one or code here in the notebook is that you select the command or the code or whatever here in the notebook, and then you can copy it and paste it directly into the terminal. Okay, you can copy it like this or with Control-C with the shortcut. okay? And then you can paste it directly here into the terminal. So this way you are going to be able to copy and paste commands faster, and you don't have to type the whole command, which is going to take you much longer. Okay, then the next command is this one, which is actually the command that we are going to use in order to create the package, ROS2 package create, etc. Then let's create our new package here. Resize this, there we go. Okay. Now we are going to go inside my box.gazebo, and we are going to create some folders. By the way, you can select more than one command at a time, and they are going to be all executed. Okay. For instance, I'm going to select these three at once now, and then I'm going to paste them here, and as you can see, all of them are executed. Okay. So I have created 3 new folders: launch, worlds, and models. Okay. Now I'm going to create 2 new files. I'm going to select these 2 commands together again. So I have created a new file inside the launch folder named startworld.launch.file, and I have created another new file inside the worlds folder, which is named box.empty.world. This is a world file. All right. Then next is to download this repository, this Git repository. So I am going to do it right now as well. Basically, this repository contains some models related to the robot, to the URDF file that we are going to be spawning later. Okay, so we need to download these models to have them available. And now what we are going to do, so all these models have been downloaded here. So now basically what we are going to do with these 2 commands is to move the models from the repo to the models folder. Yeah, so in most cases you are going to find the models or all the DAE files, STL files, etc. You are going to find them in a folder which is named models. So we are going to be moving all the models from inside here to the models folder, which is the correct structure. So let me run these 2 commands and remove this, and that's it. So now we have our package with the proper structure. Okay. Now I'm going to do another thing at this point, which is to open the code editor. All right. To open the code editor, you only have to click here in the second icon, which is here at the side of the web shell icon. So if you click here, this is going to open the code editor. All right, and this is going to give you access. You're going to be able to visualize all these workspaces and folders in a graphical way, which is always easier and more user-friendly, let's say. Then in this case, we are working in this workspace, or ROS2 workspace, right? So if we go inside the SRC folder here of the ROS2 workspace, we are going to find a couple of packages. This one, you already had it here in the rosject, and this is the new one that we have just created, my box.gazebo, okay? With all the folders that we created. You can see also the files that we created here. So here inside the launch folder, we have this start world launch py, which is the file that we created here. Also, we are going to be able to see here the world file. Inside worlds, here we have it, which at this point, of course, they are empty, right? So we have just created these files, but we haven't filled them yet. We will do this in a moment. And then, yeah, so we have also the models folder here with the meshes and everything, which is all the models that we got from the repo. Volker is asking, git clone not in the worlds folder? No, the git clone, you should do it. It's done inside my box.gazebo. Okay? So all the commands you can run them directly. Okay, so you don't have to move to different folders. All these commands are stated here so that you can run them one after another. Okay. All right. So, okay, then we have created the basic structure for our Gazebo package. So now we are going to start filling all these files, right? So the first file that we are going to fill is the start world launch py. We have the contents here, so what you should do, what you have to do is to select the contents of this file directly here from the notebook, select everything, copy it, and then you can come here to the code editor and paste the contents like this. Okay? So now I have filled it, and I have my start world launch file with contents. Okay? So, yeah, so now we are going to analyze a little bit what's going on here in this file, so what we are doing. It's very simple. So this file, what it's supposed to do is to start a world, okay? Then a Gazebo world. So what are we doing here? Well, first of all, we are getting some packages. So we are getting the path to some packages. First, we are getting the path for the Gazebo ROS package, and then we are getting the path here with the myboxbot Gazebo package, okay? For this, you can use this get package share directory function that we are importing right here, okay? This is very common to use this function in launch files in ROS2. Then also we are getting the path to the myboxbot description package, okay? Okay, then here we are generating a path, which we are storing into this variable. So we are generating a path by appending the path to the package boxbot Gazebo, which is this, and models. Okay? Why? Because inside the models folder of my boxbot Gazebo package is where I have all the models. Okay? All the models that I need for this simulation. And then what I am doing is to update the Gazebo model path. Okay, this is very important because Gazebo, in order to spawn a model into its world, it needs to have the direction, the path to this model in the Gazebo model path environment variable. Okay. If the model that you want to spawn is not inside this path, then you're going to get errors, okay? You are maybe not going to be able to see the model, etc., okay? So this is very important to always set properly the Gazebo model path. So this is what we are doing. As you can see, what we are doing here is to add the path to Gazebo models path, which is the path that we have generated here. We are adding this path to the Gazebo model path environment variable. Okay? And here we are doing the same for the Gazebo plugin path. This is the same as Gazebo model path, but for plugins. Okay? If we want to load plugins into Gazebo, they have to be inside this Gazebo plugin path. Otherwise, Gazebo is not going to be able to find them. Okay? Then here we are just printing the paths so that we can visualize them and make sure that they are right. And then here is where we are actually creating the Gazebo launch file, right? So we are setting here the path to the launch file that we want to start, which is this gazebo.launch.py from the Gazebo ROS package. Okay, so this is a default launch file provided by the Gazebo ROS package. And then, which basically it starts Gazebo, okay? And then what we are doing here is to provide the world that we want to launch, which is this boxbot empty.world. Yeah, it's the world that we have created here, which right now it's empty. Okay, we are going to fill it in a moment. Okay, so we are setting our world here as the world that we want to launch. Okay? Yeah, makes sense? So far so good? Makes sense this launch file? Do you understand more or less? So there are some things that maybe are a little bit harder, some paths, if you don't have the background, maybe it's not so easy to understand perfectly, but at least I want you to get the general idea of the launch file. Yeah? Does it make sense? All good so far, says Volker. Okay, thanks for the feedback. And then, okay, so what's the next step then? Well, the next step is to fill this world file, right? So this is what we are going to do next, right now. Then, yeah, so you have also all the things that I am explaining here, you have them also in the notebook here, probably more detailed, okay? Because I am going fast so that we don't get out of time. But you have also all the explanations here in the notebook in case that you want to check them later slowly, okay? All right, then let's fill our world file. So again, we are going to copy the contents here from the notebook, and we are going to paste them here into the world file. And as you can see, this is a super simple world file where we are only adding a model of a sun to get some light into our world, and a ground plane, which is just a plane, yeah? So that whenever we spawn a robot there, it's not going to fall into the infinite, but it's going to fall into a ground plane, okay? So these are our model, our world, as you can see, is going to be super simple. Okay, then, yeah, so we have one last step, which is to update the CMakelists.txt file, okay? So as you might know, in ROS2, whenever you have some folders here, like a launch folder with files in it, a world folder with files in it, also models, etc. If we want to make all these files available to the ROS2 system, we have to install them inside the install folder, okay? Then for this, what we need to do is to add some lines here to the CMakelist. And exactly those are these lines here, okay? These lines here, only these ones, okay? This install part here, you can copy it directly here from the notebook again, and paste it right here, before the amend package function here. Okay, so you should have something like this. Then here, what we are doing is to install these launch, worlds, and models folder. Okay, we are installing them so that all this is available to the ROS2 system once we compile our package. Okay, and this is what we are going to do right now. So we are going to compile everything. So yeah, again, let's compile. You have the commands here. So first of all, we need to go to the root of our workspace, which is this, home user ROS2 workspace, okay? Always that you want to compile, you have to be in the root of the workspace, not inside the SRC folder, not inside other folders, but in the root. So now we can run colcon build to start the compilation. There we go. It's going to take some seconds to compile. Not too long, shouldn't take too long. And there we go. And as always, after compiling, we are going to source. Okay? We are going to source our workspace like this, source install setup.bash. Okay? All right. So now we are ready to actually run our launch file. So you have the command also here. Then now we can run the command ROS2 launch mybox.gazebo start world launch file. So this is going to execute this launch file that we have created here, right? So let's run this command. And now, if everything goes okay, after some seconds, we should be able to visualize here the Gazebo world that we have started. So let's wait. You can see also here the prints for the Gazebo models path, for instance, all the paths that are inside this, this environment variable. And here we have the one that we have added. Yeah, my boxbot Gazebo models. Okay, let's wait some seconds. And there we go. So as you can see now, the Gazebo window has opened, and I should be able to see now here the world that I have launched, which is going to be an empty world. Yeah, so as you can see, this is a very, very simple world. I have a ground plane, which is this grid that you can see here, and a sunlight, which is why I am able to visualize things, because I have this sunlight. Okay? Excellent. So now we have our Gazebo world, an empty world. So now we are ready to spawn things into it. Okay? Yeah, so far so good. Have you been able to start the Gazebo world? Yes, says Volker. Also Marco says yes. Perfect. Then, yeah, so let's keep advancing. Okay, so we have started our Gazebo world. Then, yeah, so there is one thing that we can check here very quickly if you want in Gazebo. So if we come here to the Gazebo GUI, and we change here, here you are going to be by default in the world tab. You can see the models that you have here, the ground plane, lights, we have the sun, etc. If you change to the second tab, which is insert, here, and we minimize the first path, here you are going to see all the paths of the Gazebo model path, okay? And for instance, here we can see the ones that we have added, yeah? Okay, in any case, this is not so important, so you can check it if you want, but it's important that, what is important is that you bear in mind that this Gazebo model path, it's very important for Gazebo, okay? So if you might have problems that you cannot visualize your robot, etc., or Gazebo freezes, or it can have different it can cause different problems, but it's always one of the things to check is this Gazebo model path. So make sure that Gazebo has access to the models that you want to load. Okay. All right. Then yeah. So let's keep going. So now that we have started our Gazebo world, then the next step is going to be to spawn our robot inside Gazebo. So we are going to spawn our URDF file inside Gazebo. Okay. Then for being able to spawn a URDF file into Gazebo, we need to have some minimum things defined inside this URDF file. Okay. What are these minimum things? Well, you have them here. You have to define the collisions of the links of your model, the inertias, and the physical properties. Okay? So you have to make sure that the URDF file that you want to spawn into the Gazebo world has these elements defined: the collisions, the inertias, and the physical properties. Okay? If it doesn't have these things defined, then you are going to have problems. Okay? Then let's start by the first two, which are the collisions and the inertias. Okay? So the collisions are the elements that simulate the physical properties of rigid bodies. Okay? So for any link that, for every link that you are going to define in a URDF file, you are going to have basically three tags, let's say. One is the visual, which is how the link, how the model is going to look. The other one is the collisions, which defines a collision box. Yes, so how is this element going to interact with the other elements of the world? Okay? And finally, you have the inertias. Okay? Then, Yeah, so for the collisions, you can have you can define them in two different ways. One, using meshes, so using directly a DAE file or an STL file. You can provide this file and use this mesh directly as a collision. And the second one is using basic geometries, okay? If you use a mesh as a collision, then it's going to be heavier to compute, okay? So it's going to take more resources. And it's going to be more precise, of course. It's going to be more real to the model that you are simulating. But on the other side, if you use basic geometries for collisions, then it's going to be much more light. Okay. So my recommendation is that always that you can use basic geometries for collisions. Okay, because it's going to make everything easier and lighter for Gazebo to compute all the physics and all this stuff. Okay. In our case, we are going to use basic geometry for the collisions. Okay. Then, so how we can know then what is the basic geometry of our collision? Well, you need to have information, of course, about your model. In our case, the model that we are going to be spawning is this box bot, like this, okay? Then, for instance, we can have access to, we can open the mesh of the model in Blender, for instance, and then we can have access to the dimensions of this, okay? And then based on the dimensions and the shape of this mesh, we can generate a collision shape, a collision basic geometric shape that relates to this model. In this case, as you can see, it's very obvious that the collision shape that we could generate is a box, right? So we can create a collision, which is a box of the same dimensions of the model, and that would make it. So we don't need to use directly the mesh, but we can create a box which is going to be almost the same. All right. Then, so here we have a very simple structure. So here we are defining the chassis link, as you can see. This is the link for the chassis. And then we have a visual tag. Okay, the visual is going to define how the link is going to look. In this case here, we are providing the mesh, okay, which is a DAE file in this case. So here, for the visual, we are providing the mesh directly, okay? The mesh is this file that you can see here. Okay, this is the mesh. And then for the collision, we are using a box of the following size. Okay, so instead of providing directly the mesh, we are using a box for defining the collisions. And this is going to be much more lighter to compute for Gazebo. Okay, the other option is to provide also the mesh here for the collisions. You can do this also. Okay, and why the size of the box is of 0.1 if we can see here that the mesh here is of 1 meter per 1 meter per 1 meter. So the dimensions of my mesh is 1 meter per 1 meter per 1 meter. Then why here I am setting 0.1 meters instead of 1 meter? Well, in this case, it's because of this, okay? So we are providing here the DAE, the mesh directly, and we are scaling it down to this size, okay? Then in the simulation, our box, our cube is going to be smaller. It's not going to be the original dimensions, but it's going to be scaled down to this. Yeah, that's why we are using these dimensions here for the box that we are going to use for the collisions. Yeah, does it make sense so far? Are you following? Yes. Which dimensions are used on Gazebo? Meters, kilograms, and seconds. Yeah, I think so. Yes. Yes, Juan. Can I modify? Yes. Okay, so David and Jack Moore are following. Juan is asking, can I modify that? So the units use it. I don't know, but I don't think so. I don't think so that you can modify the default units use it. But I don't know, you might investigate on that. At least I have never done that. So I don't really know if it's possible or not. But yeah, I don't think so. Okay, Juan. All right, then so yeah, boxbot basic URDF. Yeah, so David is pointing to this file. Yeah. So this file is the URDF file that we are going to be using, okay? So let's have a look at this file, okay? Very quickly. So the URDF file that we are going to be spawning into Gazebo, you can find it inside this other package that you have here, my boxbot description. Then if you open this package and you go inside the URDF folder, you are going to find this URDF file, boxbot-basic.urdf. Okay, this is the URDF file that we are going to be spawning into Gazebo. So here you can see all these different links defined. So you have the chassis here, and as you can see, you can see here how we are providing for the visual directly the mesh, and for the collisions we are using a box. Okay, and then we have here also the inertias defined. Okay, you can find also the joints, extra links like the wheels. Okay, so we are going to have also wheels. Again, for the wheels, also we have a visual, we have a collision, we have an inertial tag. Okay, for each link, right wheel, you can find it here. We also have the visual, the collision, and the inertial. Okay. Do we need to adjust any script? No, you don't need to change anything here. No, David. You don't need to you don't need to change anything here. Do you scale down because of performance? No, not really. In this case, it's just to make it smaller. But you can also change the dimensions and leave them as the original ones. No problem. You can do that later. You can do your own tests. So now for the class, okay, we are going to be following the different steps and everything. But after the class finishes, you can do your own tests, okay? So you are going to have this rosject forever, as I said at the beginning, and then you can change. You can try different things here. You can, for instance, remove here the scale tag and see what happens. If you remove this scale, then of course you're going to have to change also the size of the box, etc. So you are going to be able to do your own tests later, okay? But now let's not modify anything, because if you modify things on your own, then probably you are going to get errors, okay? So now let's stick to the plan and to the notes of the class. Okay. Then next thing that we have is the inertias, okay? So the inertias are also very important it's very important to define the inertias of the different links. They are very important for Gazebo, okay? So you have to pay attention to this. And also if you set the inertias wrong, then you can have some errors. Some errors might appear, okay? Then, yeah, so the inertias are going to allow Gazebo to simulate the torque needed to give angular acceleration to the link around a certain axis, okay? So the inertias, I'm not going to go into detail on all this, but yeah, you can search information if you want to know better what inertias are, but it's not the purpose of this class. Then also how to calculate them, okay? There are formulas, there are pretty simple formulas. on how to calculate the inertias of different geometric shapes. In fact, in the course, in the 4 curls, we are providing a Python script which does this, which does the calculation of the inertias. Here, just we are providing them directly to you so that you have them. And as you can see, they are defined as well inside the link. Yeah. So we have this inertial tag where we are defining the mass of the link, okay, in kilograms. As you can see, this is in kilograms. We are defining the mass, the origin, which we are going to see in a moment what these origin tags are. We are defining the mass and the inertias, okay? So the formulas to calculate the inertias of a box are different of the formulas to calculate the inertias of a cylinder, or of a sphere, etc. Okay, but we are not going to get into that because that would be too much. Okay, but you have to know that it's very important to define the inertial tag in your URDF file. Okay, then we have this origin tag. Yeah, so if you pay attention to all these tags that we have talked about, the visual, the collision, the inertial, all of them have an origin. Okay, so sorry for that. So this origin tag allows you to change where, for instance, in the case of the collision here of the wheel, which is a cylinder, you can change change the position of this collision box, for instance. Okay, of this collision cylinder. In this case, for wheels, of course, it's going to be cylinders. But for the chassis, which is the basic example that we were seeing, so you can change here with the origin tag. In this case, we are not using anything, but here, as you can see, we can, if we, for instance, change this here, we can change where this collision box is going to be, okay? With respect to the visual, okay? Usually you are not going to have to do this, but it can be useful in some cases, okay? So you can lower, for instance, the collision box in some cases. Usually you are not going to have to do this kind of stuff, okay? So usually you are going to find situations like this one where the origins are all the same for the visual, for the collision, or for the inertias, okay? But this is a possibility, just so that you know, okay? Yep, there we go. On RPY, for the change degree of object, should we change X, Y, Z in the origin? For changing the degrees, no. The X, Y, Z, okay, I can see here, on RPI the dimensions are radians or degrees, okay. So, good questions, okay. So the origin has two tags. X, Y, Z, it's just the X, Y, Z coordinates in the polar system, okay. Then to change the orientation and so on, you're going to change RPY, which is roll, pitch, and yaw. Okay, this is the roll, pitch, and yaw values, and these are in radians, okay? So this is 0 radian, this is 1.57, so this is P, this is P divided by 2, okay? So this is the X, Y, Z coordinates, and this is the roll, pitch, yaw, okay? All right, and then we have one last thing, which is the physical properties, okay? Then we can provide some special tags like this, which are the Gazebo tags, where we can provide some physical properties for the links, okay? For instance, these are the typical ones. There are more, okay? But these are the typical ones. So what I am indicating here is the material that I want this link to be in Gazebo, okay? Chi-P and Chi-D, for instance, are values that define the stiffness, let's say, yeah? You have the explanation here, but KP and KD define the stiffness of the object. So if the value here is very high, the object is going to be very rigid, okay? And the mu's are friction values, okay? Are just friction values. So the static friction and the dynamic friction, okay? So these are friction values also. I'm not going to enter into that. These are things that you learn usually in the university when you are doing physics and this kind of stuff, okay? But you can define all these things as well in the Gazebo tag, okay? So for instance, if you spawn a model in a Gazebo world, yeah? If you spawn a model in a Gazebo world, let me change here to this other camera. So if you spawn a model in the Gazebo world and you see that the model starts moving without you doing nothing, then probably is that the frictions are too low. So you might have to tune these frictions, okay? And I cannot tell you a better way to do this, but by testing, okay? So you can test different values and see which one are the best ones for your specific robot, okay? So we can have a look also at these tags here, for instance. So for the left wheel, we are defining here the KP and KD. These are very, very high values, which means that the wheels are going to be rigid objects. Yeah. If these values are low, they are going to be more they are going to be like more flexible materials, like something similar to plastic and this kind of stuff. Okay. In our case, we want our wheels to be rigid. And we are defining also the static and dynamics mu's values here. So the frictions of our wheels, okay? And finally, we are defining the material. So we want our wheels to be green, to appear in green color in Gazebo, okay? You have many different materials. For instance, I left here in the notebook some links in case that you want to see all the materials available. You can come here to this link and you are going to find all the materials available, and also many more options that are inside the Gazebo tag, okay? So we have just seen some of them, but there are many, many more, okay? So inside Gazebo tags, for instance, is where you are going to define plugins for the sensors. Like, is where you are going to define and configure, for instance, a plugin for the laser. In case that your robot has a laser, you are going to define this inside the Gazebo tag. Or you can also define a differential drive, for instance, for the wheels, for controlling the wheels, etc. Okay? But we are not going to enter into all that because that would be too much, okay? So we are going to check only the basic stuff, which is what we have seen, okay? So the basic stuff that your URDF model has to have so that you can spawn it properly into Gazebo are the proper link definition with the visual, collision, and inertial tags set, and Gazebo tags. Okay? So that you can properly define the properties, the physical properties of your links. All right? Oh, sorry. Yeah, I left it here. Okay. Yeah, now you're going to see again me. Yeah, so I was only saying that this is the basic stuff, okay? So there are many extra things that you can add to a URD file, as you already know. We are not going to cover them. You can define all the sensors. You can define the ROS control, the ROS2 control part in this case. We are not going to be covering all this in this open class because it's impossible. There's no time, okay? But all these things are covered in the course, okay? So the course that I shared at the beginning and that I'm going to share later, the complete course has all these things explained, okay? So how to add sensors here, how to add the ROS2 control configuration to the URD file, etc. Here we are just defining the basic stuff that we need in order to spawn the model, which are the visual, collision, and inertial tags, and the Gazebo tags, okay? And of course, well, the joins, which of course you need them because they are going to connect one link with another. Okay? All right, then, yeah, so basically we have the basic structure. We have explained all the different things that we need, the most basic things that we need in order to have a minimal URDF file that we can spawn into Gazebo. So now the last step is going to be to actually spawn this URDF file into Gazebo, right? So for this, we are going to do some extra things here. So we can leave our world here running, okay? We don't need to close it or anything. So we can work in another terminal. Then we are going to start here by going to the myboxbot Gazebo package. And then we are going to create two new files here with the touch command, okay? So we are going to create here two new launch files. This spawn robot ROS2.launch.xml and this spawn robot description.launch.py. Okay, and then we are going to create also another launch file inside the myboxbot description. So we are going to go now to this other package, myboxbot description, and we are going to create here another launch file, which is going to be named publish urdf.launch.py. Okay. Now here we have the contents of these launch files. So first of all, we are going to fill in the contents of the spawn robot description.launch.py. So let's come here to the code. To the code here. Yeah, let me grab here this. See if I can. There we go. Okay, so we copy the contents of this first one, spawn robot description. We have here spawn robot description.launch.py, and then we paste the contents here. And we are going to do the same with the other launch file, which is publish urdf.launch.py. So let's do it. Let's first copy the contents, and then later we are going to see what we are doing here, okay? Let's get this. Okay, so this one, we have it here, publish urdf.launch.py. And finally, we have this one, which is spawn robot ros2.launch.xml, which we have here, spawn robot ros2.launch.xml. Okay. So what are these three launch files that we have just created doing? So let's start by the first one, which is this one, spawn robot description.launch.py. So basically what this launch file is doing is it reads the robot description topic and spawns in the given position and orientation whatever it finds inside this robot description topic. Okay? So basically, let's open this. Let me put it here. Okay. So this spawn robot description launch.py file, what does is, so first of all, we are defining here a position and orientation, okay, which is X, Y, Z. An orientation which is also in roll, pitch, yaw. So this is in radians, okay? And then we are calling here the spawn entity script from the Gazebo ROS package, okay? So this spawn entity script, it's already provided by the Gazebo ROS package, so you don't have to create it, it's provided by default by this package. And then you can use this script in order to spawn something, spawn a model into Gazebo, okay? Then what do you need to provide here? We need to provide some arguments to this script. First, a name for the robot, okay? In our case here, we are using boxbot plus a random number, okay? Just in case that we want to spawn different robots, then we can do this by attaching here a random number, okay? Yeah, but this is not so important. So basically, we need to provide here a name, an entity name, and X, Y, Z coordinates where we want to spawn the robot in the world, and a roll pitch yaw orientation where we want to spawn the robot in the world. Okay? So later, you can also try to change these values and see how the robot is going to spawn in a different place in the world. Okay? You can try this later if you want. And then finally, we provide a topic name, which is robot description. So in this robot description, what we are going to have to publish into this topic is basically the contents of a URDF file. Because then this spawn entity script is going to get these contents and it's going to spawn this URDF file into the world in the provided position and orientation. Yeah? Makes sense? So now what we need to do is to have something published into this robot description topic. Okay? Then this is what we are doing in this other launch file, in publish URDF launch.py. Okay? So in this launch file, what we are doing is that we are putting the contents of box.bot basic URDF. So we are putting these contents into the robot description package topic. And how we are doing this? We are doing this by using the robot state publisher node. Okay? So we are using the robot state publisher node here from the robot state publisher package. We are using this node in order to put the contents of this URDF file into the robot description topic. Okay? So we do this so that now, later, we can get the contents from here and spawn them using this script into Gazebo. Yeah? Then we are doing another thing here, which is to start an ROS2 node, but this is not mandatory, actually. This is an extra thing, okay? So you can remove this if you want, but we are doing an extra step here, which is to also start ROS2, okay? Yeah? Makes sense so far? Do you get the general idea what we are doing here in these two launch files? Yes, so far. Okay, very well. And then finally, in the third one, what we are doing is to run these two launch files. Okay? So first, we run the publish URDF launch.py. So first, we are going to execute this launch file. Okay? This is a special launch file. Well, it's not a special launch file. It's another format of launch file. Yeah? So very often you are going to find ROS2 launch files like this as Python scripts. In this case, we are creating an alternative version, which is using an XML. Okay? So ROS2 provides support to create also launch files in XML format. Okay? And usually it's easier to create them. Okay? Also, they are more similar to the ones of ROS1, so it's easier and faster to create them. Then, so finally in this one, which is the one that we are going to actually execute, what we are doing is to include the other two launch files. So first, we are going to run the publish URDF, this one, so that we put the contents of our URDF file in the robot description topic. And second, we are going to run the spawn robot description, which is this one, which is the one that's going to take the contents from robot description and is going to spawn the URDF file into the Gazebo world. Okay? So, so we have the basic structure with all the launch files. So, what now? Now we are going to compile. So we are going to compile again to install all these new launch files that we have created. Let's compile and source, very important. And now, finally, we are going to run. Well, this step is not required in my case because I have already my world running here. I don't need to launch it again. So if you have your world already running, you can move to the second part, which is this one. Yeah? So now we are going to run this command, which is going to execute this spawn robot ROS2 launch XML. Yeah, it's this, which is this launch file that we have just examined, that contains the other two launch files. Okay, so now I'm going to run this. Let me put the world here and get closer here to the center. Yeah, because I know that the robot is going to be spawned in the center, right? It's going to be spawned there. Close this point here, where these axes are coming from, this is the 0, 0, 0, okay? And I know that my robot is going to be published here because this is the position that I am providing, 0, 0, and 0.2 in the z-axis, okay? So, yeah, so now if I run my script, I should see my robot spawned here. So let's run the launch file and let's see what happens. And there we go. So here we have our robot spawned, yeah? With the chassis, which as you can see, it's the die file, with the wheels. Here it also has a caster wheel here in the front, as you can see, okay? So, as you can see, it has also automatically opened here RVs, right? But yeah, you can close RVs if you want, it's not important here. And by the way, you are going to see some errors here, okay? So for instance, in the robot model, you are going to see some errors, some missing transforms here. And also here in the shell, you are going to keep getting this message, this warning, okay, which is invalid frame ID. Why all this is happening? Well, this is happening, just so that you know, this is happening because we are not starting the joint state publisher, okay, which is very important also for this. But again, we don't have time for everything, so this is not explained here, but it's explained in the course, okay? So let me one more time remind you. Yeah, so basically this is the end of the class, okay? So we have achieved to publish everything. And yeah, so again, if you are interested in this, if you want to keep learning, you have in our academy the complete course on URDF for robot modeling in ROS2. Okay, it has been published today. So yeah, in this course you are going to have access to all these things that we have missed and many more. Okay, and yeah, I have been kicked out again. I don't know what's going on actually, but yeah. So basically, this is all for this class. Is there a good editor for the URDFs? Yeah, there are some editors. I know that there are some editors that allow you to visualize in real time the URDFs that you are creating. I don't remember the name right now, Volker, but I know that there are some very interesting editors that allow you to visualize the URDF and this kind of stuff. But I cannot give you the name because I don't remember right now. But if you look out there, you're going to find some for sure. So yeah, let me stop everything here. There we go. Okay, so yeah, thanks a lot for being here with me during this hour in this open class. I hope that you've liked it. I hope that you have enjoyed this class, that you have learned something new. And yeah, thanks again for being here with me. I'm going to come back next Tuesday with the next open class where we are going to be talking a little bit about TF, transforms in ROS2, okay, which is also very closely related to URDF files. So if you are interested, don't miss next open class. And until then, as always, take care and keep pushing your ROS learning. Bye-bye.